the technical issues. And more recently, we have introduced PFPNet eTech, and that is a separate organization which is going to be delivering training for individuals involved in fire protection. But that is a run for not non-for-profit organization, that is actually a commercial organization. And the idea of this is that PFPNet eTech will sell training, and the revenues that we receive for the training will then be used for the benefit of the technical subjects that we want to address under PFPNet, the original PFPNet. So a split organization these days, but still with the same objective of increasing knowledge and understanding and standards in the industry. Gios, next slide, please. So PFPNet membership, as you will see there, is made up by a fairly large group of organizations. There's a couple missing off this slide, which needs to be modified, including Shell, Lloyd's Register. But essentially, it's a lot of companies that are involved either in owners of installations or engineering companies, suppliers, etc. So quite a broad spectrum of members. Next slide, please, Jos. So today's meeting is really to talk about tunnel fire protection. And some time ago, PFPNet recognized the severity of oil and gas fires to those that occur in tunnels. And we formed the Tunnel Fire Protection Group. This is currently chaired by Case Both of ETEX. It's a small group within the organization of PFPNet, but one which is obviously looking specifically at tunnel fire protection. And so far, that group has developed several documents addressing fire protection in tunnels, most recent of which is the guidance document, which we will be presenting throughout this webinar. Next slide, please, Jos. So, rules of the webinar, please. No interruptions, if you may. Please put your microphones on mute and please put your cameras off. Questions may be asked during the presentation via the chat functions, and a limited number of questions will be answered at the end of the presentations. And then if we just get overloaded with questions and we don't have the time to deal with them all other questions will be answered through email. And I'll come on to how that's going to get done a bit later during the closing session. Next slide, please, Jos. So kicking off, we have consequences of fire in tunnels. Talal's going to present that. And then solutions and assessment methods, Jos is going to present that. And Kisboth and Aibaka will be moderating the chat box. So those guys are going to be doing a good job for us today. Right, so that's me pretty much completed. We can go into the presentations if we want to start, please.
So, good morning, everyone. My name is Talal Fateh. I am the manager of Fictis UK. Before start the presentation today, I just want to take 5 minutes to present who is Fictis, what we are doing, and why we are here today. Next slide, just. So 20 years ago, the Dutch Public Research Center, TNO, with the French metallic construction company, CTCIM, created company named Fictis, dedicated to the fire safety. We are based on our testing culture, so we are trying to test everything as I can. However, testing is not enough. So you need to have a look at the fire engineering and the certification, including inspection and approval. Just the next one. After 20 years, today we are more than 300 staff. We are operating 19 locations across Europe, 5 countries in Europe. We have today 7 fire testing laboratories. According to our database, we conducted last year more than 10,000 fire tests. Next one, just. To summarize our service, we are working in 2 different scales. The first one is the product scale. We are working with our client to assist the fire performance of the product and provide the relevant certification, such as not limited to CE marking, UKCA, or our voluntary system effective certified. However, we can work as well at the project level, where we can assist a system to understand the fire performance of a system in the real life or in the real application. Next one. As I mentioned, we are testing fire engineering company. We are covering reaction to fire, fire resistant. Sometimes we need to do special tests. It can be large scale or adapted test. We are able to provide the certification, and also we are working in the fire engineering and we have teams to cover inspection and expertise. Next one, just. We try to, as I mentioned, Effectis is dedicated to the fire. However, our market is not limited to public buildings, high-rise buildings, but also we are working in nuclear plants, transport area, infrastructure, oil and gas. Next one, just. If we would like now to come back to our topic, let us all agree that each fire is a specific scenario. We cannot, unfortunately, investigate that scenario. The problem today, if we are talking about the tunnel fire, I don't want to use the word complex. I will use the word of different. Why is it different? Next slide, just. It's different because I have ventilation, oxygen, it's available. The location of the ignition can be changed across the tunnel. The tunnel itself, the dimension of the tunnel itself can be different from one to other. If we're talking about the fuel load, this can be a few megawatt. If we have a fire started from a car, where it can be hundreds of megawatts when we are talking about lorry or maybe petrol tanks. We have several issues can happen in the tunnel and only in the tunnel. For example, we can have the back lighting, that the smoke stagnate at certain level in the tunnel. We can have what we call the moving fire. If we are talking about a train has a fire and that train, it's keep going ahead across the tunnel. And of course, the tunnel fire has a consequence during the accident and after. Next slide, please. Next slide. So, to respect the time dedicated to me today, so I just select a few items to present what consequence we may have during a fire in the tunnel. So I will try to present in briefly a few items. Of course, you may have something extra, but the objective of today it not to go all to cover all of them, just maybe to have a quick view what can happen during this accident. Next one, just so if we start with the hazard from the fire, as you can see in the picture, a fire in a tunnel will generate a lot of smoke, a lot of heat. As we know that smoke toxic, we know that we are generated a lot of gas such as CO, HSN, etc. But the gas itself, it can be different from fire to other due to the variation of the scenario, like fuel, ventilation. And also we should not forget that we have all the time a risk of explosion. The next, just. One of the main issue we have in the tunnel that we may need to evacuate a large number of people involved in that fire. The issue, and for some reason, and I believe everyone observed it, that when we are doing a training or fire drill, the evacuation is going to happen all the time, 100% successfully without any problem. The issue is that when we have a real fire scenario, we are acting in different way. We will act different when we are alone, and also we will act different when we are in the group. This can lead to increase the evacuation time. Increasing the evacuation time will create, or maybe it will create more probability to have more accident and injury and increase the fatality of that accident. So we need to pay attention how we evacuate all that people without having any problem. And for some time, the people themselves, they create another accident or maybe enhance the fire to spread during the fire in the tunnel by doing the wrong things. If we go next one, just please. Of course, a fire may lead to lose the power system in the tunnel or the area surrounded. What it means, we may losing the lighting, the ventilation, communication. And also we are losing the function of that tunnel. It can lead for important significant traffic. And also we may need to close the tunnel, not only during the accident, but also we need more time to investigate and understand why this happened, and also later a significant time to repair it. Next one, just. So if I'm talking about the reparation, so we can cover the economic cost, but also we should not forget that during the maintenance or in this phase, we need to have another solution for our needs. So logistic can add an extra cost. We should not forget the environmental cost. We are talking about the pollution of the air, of the water. Sometimes when we have a lot of severe fires happen in the tunnel, people may lose the confidence in the safety of the tunnel infrastructure. Next one, just. And the most more important things is how the damage in the structure of the tunnel. One of the main structural problems in the tunnel exposed to fire is the serious damage caused by explosive spalling of the concrete. How we next one? How we can reduce all these negative things to happen? Of course, not limited to good design, good detection, enhance the maintenance, inspection, train the staff of the management company operates that tunnel, but also as we are talking today about the passive fire protection. So the next one, just why passive fire protection? Because the fire passive protection will support the evacuation and firefighting activities, and also will reduce the impact of the fire structure and also protect the technical installation of the tunnel. This lead to minimize the economy and the cost of the fire, and this will give us more life cycle for the assist. Before, just last one, please. At the end, I would like to, before passing the presentation to my colleague, I would like to raise another issue coming from the new technology that today we are talking about hydrogen batteries, more complex design in the tunnel. So all this is changing the safety risk, including the fire in the tunnel. And this need to be considered in any further investigation. I hope I respect my 10 minutes just. So sorry if I use it more. So I will leave it for you now. Thanks.
Right, thank you, Talal. All right, so if all is well, you can hear me. If not, please let me know.
We hear you.
Yeah, thank you, John. So we will continue with an introduction to the guidance document Effectus has written for PFPNet. And we will focus in this presentation on solutions and assessment methods. So my name is Jos Bieneveld, and I'm a project leader at Effectus, the fire engineering department. So my main involvement is in fire resistance of concrete structures, mainly tunnels, and also protection of these concrete structures. So I'm a co-author and editor of the Effectus R0095 procedure for testing of tunnel linings. I'm also co-author of the guidance document. So this is my email address and my telephone number. So the intent of the guidance document is to give a primer for those not familiar with PFP in road tunnels. And for PFPNet, the interests are that the tunnel fires are severe and similar to industrial fires, fires that other PFP members are familiar with. And the hazards are also becoming more similar, for instance, hydrogen and batteries. So the scope of the guidance document is at the moment only road tunnels, but other tunnels are also considered for future developments, for instance, rail tunnels. The focus is mainly on tunnels made of concrete, but part of the document may also be applicable to other building materials. The focus also on protecting the main load-bearing structure of the tunnel, and focuses on added-on PFP. And only legislation from the UK, France, and the Netherlands is included in the guidance document. So the basic structure of the guidance document is as follows. It starts with an introduction and has three parts: an overview, a part with the design phase, and a part about operational phase. So in part one overview, a high-level overview is given of the steps necessary to implement passive fire protection in road tunnels. right? It discusses major incidents, gives a high-level implementation chart, gives examples of PFP, and discusses alternatives. And also discusses active fire protection with an emphasis on fixed firefighting systems. Part 2, design phase, discusses the design of PFP, gives more in-depth knowledge about tunnel structures, role regulations, procedures and guidelines, as well as risk assessment approaches. And this section ends with testing of passive fire protection. And in part 3, the operational phase is discussed, which includes installation, maintenance, and possible repair. So for this webinar, I will focus on only implementing PFP and examples of passive fire protection in tunnels from part 1. So let's start with implementing passive fire protection. So this is the implementation chart that we've made with 7 steps that you should take for implementing passive fire protection in road tunnels. It starts off with identifying key tunnel characteristics. For instance, if it's a tunnel under open water or if it's only a land tunnel. The next step would be to check relevant law and regulations. The next step is to perform a risk assessment study. And based on the risk assessment study, a fire protection system can be chosen. That system has, of course, to be tested for conformity. And if it fails, then you are back to step 4. Well, if a system has been chosen and it conforms to the specs, you can go to installation, and after that, of course, maintenance. So now I want to discuss the most common types of passive fire protection that are used in road tunnels. Mainly 2 types exist, based on spray applied mortar or based on fire-resistant boards. And at the time of writing this guidance document, I'm not familiar with intumescent coatings that are in use in tunnels. However, I know that developments are being made. All right, so let's start off with an example of spray applied mortar. So this is a picture of spray. Sorry. Right, we'll continue. So this is an example of spray applied mortar in a tunnel. You can see here it's applied to the wall, but it's also applied to these beams to the ceiling. The beams on the ceiling still have the rough surface that shows after applying the spray applied mortar. But on the wall, it's nicely troweled to cut down the unevenness and give it a smooth appearance. And it was also painted. So now an example of a board system. So this is a board system, what we usually refer to as a post-fixed system, which means that it's installed after building the concrete structure. It can also be done differently in a way that boards are placed in the formwork before casting and concrete is poured over the boards. And the boards are actually attached to the concrete. But in this example, it's a post-fixed system and it's fastened to the concrete with stainless steel nail anchors. This is a basic system in that the joints are butted together and it's placed directly against the concrete. Such a system can also be painted to make it more appealing. This is an example of a system that's mostly similar to the first one that I've showed. except for the fact that this one has strips on top of the joints. That's usually done to prevent excessive high temperatures at the joints. It is usually so that for a system with butted joints, that the temperatures are higher at the joints, and that may induce fire-induced spalling at these joints. And to prevent that, sometimes front strips, like in the left picture, are used, or sometimes what's referred to as backer or backing strips. So in that case, the entire system is placed on a system of strips, and the main boards are actually lifted from the concrete and not in direct touch with the concrete. The board system may also be applied to a bored tunnel segment, as used for TBM tunnels. In this case, a faceted system is used, so rather boards with a small width are used, and this system is also placed at the joints on backing strips, and it's also attached with stainless steel anchors. So another variety that you see in practice is that the fire protection boards are installed to a steel structure. So in this case, because the back of the board is not in touch with the concrete doesn't work as a heat sink. So these boards are usually quite hot at the back during fire. And as a consequence of that, sometimes a thicker board is used in practice. And another example of a fire resistant board system is this nice system with a nice smooth layer attached to its to the tunnel side to give it a nice smooth appearance. So now we will continue with part 2, the design phase, and for this webinar I will be discussing testing of passive fire protection. So testing may be divided in the following tests. So reaction to fire tests. These are a main concern in the beginning stages of a fire. Fire resistance tests and other tests such as frost thaw cycle tests, fluctuating air pressure tests, and tests to check the resistance to chemically aggressive environments. And the exposure and aging tests are mentioned in these EAD documents. So on the European level, there's no harmonized fire resistance testing standard or classification systems for PFP and road tunnels. So in other words, testing at the high temperatures that may be expected at the most severe tunnel fires. So actually every country arranges this on a national level. And the guidance document describes the procedures for France and the Netherlands, since there's no specific UK procedure at this moment. But before we go there, let's check the most common fire curves. So for buildings, the ISO 834 standard curve is normally used. And when we compare that to other curves that are used in tunnels, for instance, the RWS fire curve, we see that that curve has a much higher temperature, peak temperature of 1350 degrees Celsius. But also, which is quite important, is that the tunnel fire curves rapidly rise in temperature in the beginning stages. So for instance, the RWS fire curve goes in 5 minutes to more than 1100 degrees Celsius. And that has a big impact on the tunnel structure, the concrete tunnel structure. And because of the rapid rise, that might induce fire-induced spalling. So in the Netherlands, the RWS fire curve is used. In France, the HCM fire curve is used. And I've also included 2 other fire curves that come from Germany, the RBT 30 and 60 fire curve. So testing fire protection, passive fire protection in France. So the demand there is a A2S1D0 for reaction to fire. And for determining the fire resistance, C2 has published a guide called Passive Fire Protection Systems, Justification of Performance for Road Tunnel Structures. If you Google this, you can find it on the website of C2 and you can download it for free. The C2 test is actually based on a European test standard, EN 13381-3, but it substitutes the standard fire curve for the HCM fire curve. And it describes more instrumentation than on the European standard. So the safety guide only describes a method to determine the characteristics of passive fire protection, but it doesn't focus on the spalling properties or other fire properties of the concrete structure. Those are not considered. So based on the required safety level in the tunnel, different fire curve is chosen, or actually the length of fire curve is different. So if you go to the highest safety level, in this case N3, you should do a 4-hour test on the system, of which the first 2 hours are the HCM fire curve. And after 2 hours, it picks up at the standard fire curve to the end, to 240 minutes. And there's an overlapping period between those two fire curves because you have to go down in temperature, of course, which cannot be in one big step. Check. So a couple of remarks about this test procedure. So for this test, there is tensile stress in the lower reinforcement bars of the concrete slab. There's no furnace pressure criterion. Structural failure of the PFP system is not allowed. And fire resistance is based on a maximum characteristic temperature and exposed phase of the concrete. What is also good to mention is that this definition of characteristic temperature, which is taken from the European standard, differs from the definition that's used for the Dutch case, so differs from the definition used in the effective R0095 procedure. So continuing with the Dutch case. So in the Netherlands, the reaction to fire should comply to BS2D2. And for fire resistance, effective R0095 is used. And this one is also freely available from the effective website. This procedure describes two kinds of tests, a spalling test and a thermal insulation test. So for the spalling test, the concrete structure is also considered and should be representative of the structure that is used in the actual tunnel. So for the spalling test, the spalling behavior of the concrete is important. So for the thermal insulation test, that's not the case, and it's solely a test to determine the fire resistant properties of a fire protection system. So for a spalling test, the heated area is a minimum of 5 square meters for unprotected concrete and 8 square meters for protected concrete, so concrete protected with a passive fire protection system. And the concrete test slab should have a thickness the same as in practice, but let me limit it to 40 centimeters. And for the thermal insulation tests, there are actually two types of tests, a large scale test and a medium scale test. So the large scale test should again have a minimum area of at least 8 square meters, and medium scale test has a minimum area of 1.15 times 1.15 meter. So in the latest version of the procedure, the medium scale test is only intended for R&D purposes. So actually, if you want to know the fire resistant properties, you should do a large scale test. So this is what is described as a system to be tested. What is important in this picture is that a full board is used in the middle, so a board with full dimensions, because smaller boards behave differently at fire conditions and may deform less than larger boards. Behind the boards, thermocouples are placed to measure the interface temperatures, so actually temperatures of the concrete surface behind the boards. And also the temperatures are measured at the joints between boards. As special joints, let's say, such like the T joint on the left and the X joints on the left have a separate thermocouple to measure the temperature over there. So for the spalling test, the compressive stress level in the concrete shall be representative of the actual conditions in the tunnel. The reason for that is that the spalling behavior of concrete is influenced by compressive stresses. Also, the concrete mix, reinforcement, etc. should be representative of the actual design. For the thermal insulation test, only the thermal properties of concrete are considered. So for this test, there is a furnace pressure criterion, an overpressure of 50 pascals. And in this case, again, structural failure of the pacifier system is not allowed. So in the Netherlands, the following requirements are applicable. So for the concrete surface, the temperature may not be higher than 380 degrees Celsius and spalling may not occur. And for the first structural reinforcement layer, the maximum temperature is 250 degrees Celsius. So now I would like to give you an example of a test on a concrete slab, a test that was unprotected, so meaning that it didn't have a pacifier protection system, and also no PP fiber was added to the concrete mix. So this slab has a length of 5 meters, width of 2.4 meters, and a thickness of 40 centimeters. And the actual heated area has dimensions of 4 meters by 2.4 meters. So this slab was loaded to induce compressive stresses. It was loaded to 10 megapascals on the heated side using this blue loading frame. And it's placed on top of the Effectis large fire resistance furnace. So this is a picture from the inside of the furnace before the test. So you can see nice smooth surface. And this is the result after 20 minutes testing with the RWS fire curve. So you can see here the first reinforcement layer was exposed due to heavy spalling of the concrete. This specific sample had a concrete cover of 70 millimeters. So as a minimum, 70 millimeters has been lost already in 20 minutes, but the test time is actually 2 hours. So you can imagine if we would have tested longer, that we would have gone through this slab at some point. So this is another picture of the slab hanging in the air. And this is a more detailed picture closer to the reinforcement layer, at which is shown that spalling was actually beyond the first concrete layer, of first reinforcement layer. And this is a picture of how much concrete was on the floor of the furnace. But I think these pictures clearly show that for most concrete mixtures, and especially prefabricated concrete, special fire protection is needed to prevent severe spalling of the structure. This is a picture of a TBM segment tested in the on the affected large furnace. So in that case, we both have a force in the horizontal direction with the blue loading frame, and a force in the vertical direction with the red loading frame. So we will continue now with a special kind of testing that Effectus has done many times, and that is testing concrete structures on site in an actual tunnel. So for already existing tunnels, it's not possible to bring concrete to the lab. So for that reason, we go to the to the tunnel with our furnace. So Effectus developed a small furnace for that, which has a heated area of approximately 1 by 1 meter. And it can be used for testing on the wall, but also can be used for testing on the ceiling of a tunnel, and is able to reach these high temperatures of the tunnel fire curves. The mobile furnace may also be used at other sites. It's not only used in tunnels. So to give a more detailed picture of how it looks like, it's a complete system, furnace system, small furnace system in this red frame. So there is a box with dimensions of 1 meter by 1 meter by 50 centimeters, and one large burner at the top here with a heat output of 400 kilowatts. So this is an example at the wall. And this is an example at the ceiling of the tunnel. So then we come to the last part of the guidance document, which includes installation and repair and maintenance. And there's also an appendix which goes in more detail about the behavior of concrete at fire conditions. But for this webinar, we will not discuss these subjects. So I think we have come to the Q&A section of this webinar.
So Jos, thank you very much. I have 5 questions that I picked up from the chat box.
All right.
If you agree, we will tackle them one by one, and maybe the answer leads to more questions. And so that's all fine and good. Maybe the first one to start with, just in chronological sequence. It's from Madia from RWS. Are the boards in the post-fixed system resistant to shrinkage and expansion of the concrete? So if you have a post-fixed system, is there any resistance or any test that would allow to assess the behavior relative to shrinkage and expansion of the concrete?
Well, it's actually more of a question for a producer of the boards, I think, because this is not for during fire, right? This is a question for the normal shrinkage of the normal behavior of a tunnel structure, probably.
Maybe you can expand a bit, because a post-fixed system obviously has limitations as to what it can cover if you have a dilatation joint. So in the case of an immersed tunnel, if you have dilatation joints, you probably have a different setup to accommodate indeed, for shrinkage and expansion.
Oh, indeed, yeah, I understand you now. So maybe I can go back a bit to this picture. Let me check.
And whilst you're looking, you may also want to expand on the difference between the modulus of elasticity of the boards and the concrete.
So it's actually referred to this one, right? So indeed, at joints between tunnel sections, You should design for that, of course. At these points, a different design is used, also for different reasons. The first reason is that these dilatation joints are more vulnerable to high temperatures. So from what I remember is that the temperatures should not be higher there than 70 degrees Celsius normally behind the boards. So usually you need more insulation at joints and tunnels. And also the board system should be designed in a way that differences between the tunnel sections can be, how do you say it, accounted for. Right, so I think there are overlapping boards there that can move with respect to each other and still seal the, or at least still cover the seal that's behind it.
Okay, thanks, Jos. We may need to move on to the next questions. My addition to that would be that the modulus of elasticity of the boards is much less than for the concrete. So any behavior due to shrinkage or expansion could basically be accommodated for, but for the dilatation joints, you need to design a special protection system. So the next question would be from Gerard. Is spalling also expected within the ISO 834 fire curve?
That depends, of course, on the mixed design and the complete structure. But I have seen in the past that also at the ISO curve or the EN 1363-1 curve, spalling might occur. So yes, spalling may also occur with these lower temperature curves.
Thank you, Jos. Thank you. Next question is from Lucia. What are the requirements for the decorative boards? Are they tested together with the fire boards?
Yeah, so maybe you can put it on the screen again. That's this picture. So what's actually done here is that a thin layer of decorative material is actually glued to the fire protection board. So what you see here is actually the fire protection board, but with a thin layer on top of it. So they're not two separate pieces. It's actually one piece. And in this case, to make it even prettier, the boards are hung on the wall with a special bracket system. I think that answers the question.
But yes, in general, I would argue that there may not be specific requirements for the decorative boards themselves fire related. So if they would fall off during a test, it wouldn't necessarily be a criterion, right?
No, indeed. There's no special criterion for the decorative layer, indeed. No.
Okay, the next question again is from Adia from RWS. What information can we get from a spalling test? Can we only conclude whether the concrete is spalling?
Yeah, I think that's also a good question. So if you would test unprotected, so with I'm sorry. So if you would test unprotected, so if you would test unprotected, there's no passive fire protection system, so no thermocouples on the concrete surface. I think such a test will only give in the end if concrete spalls, or if it not spalls, or if it spalls not as heavy, so you would have a certain spalling depth that might still be acceptable. But it doesn't give much more information than that. So to actually design a fire protection board system, you should do a test with a board system or with a spray applied mortar system to see what the temperature development is at the surface of the concrete. And this spalling may occur in that case, even though you have a passive fire protection system installed. Such a test would give information you could use to design a system that does withstand, or at least that brings the temperatures down in such a way that spalling is prevented.
Yeah, so my addition would be that depending on where the spalling actually occurs, and hopefully you have some thermocouples there, is that you could deduce also implicitly a bit of a rate of spalling. So the time at which spalling occurs, a bit of a rate, and eventually the depth after the fire test, as well as perhaps a total amount in kilograms, if you like, of what has spalled off, which
yes, and
arguably might be sufficient, but it depends a bit on where the spalling occurs and whether you have thermocouples at that position.
Yes, I think maybe in addition to that, it also maybe indeed depends on the position of spalling. So if spalling occurs at the joints, then you might go to a system that has actually lower temperature at the joints, for instance with backing strips or front strips.
Yes, so indeed you might get quite some detailed intel, but it certainly depends if you have a thermocouple there. So at the temperature at which, the time at which, etc. So yeah, good instrumentation is key, I suppose. Thank you, guys. So we have two, I think, other questions in the chat in the meantime. Again, one from Lucia. A quick question. She hints at Talal to answer it, but I leave that up to you, Jos and Talal, to have a fight amongst the two of you.
No, I think Talal can answer it, of course.
Yeah, of course. So Lucia says, she says, we can see in many road tunnels that emergency doors to ISO fire curve are installed in walls, which walls are designed against the RWS fire curve. What is the requirement for emergency doors when the structure is designed to the RWS curve in road tunnels? This is a tricky one, as we know in NFPA 502. We're debating this as we speak. But Jos, Talal, you want to have a go at this one?
Yes, it's a very good question, but we should not forget that it can be linked to the national level. So each regulation may insist to do some level, but normally we are talking about 2 hours integrity according to 16.3.4 part 1.
Yes, maybe you can add to that in the Dutch case, the tunnel doors should actually have a fire resistance level of 2 hours based on the RWS fire curve. So that's a more severe case than that's in the question. So actually in the R0095 procedure, it's referred to the European standard, but the fire curve is substituted for the RWS fire curve, and also different pressure criterion is used there. So we normally use 50 pascals at the top of the tunnel of the door structure, and that's much higher than you would have in the European test, and it has an influence on the performance of the door. And also we usually test the door in a concrete wall instead of a standard supporting construction. So in the Dutch case, we actually test at these higher levels that we also do for the concrete structure.
Yeah, so in addition, perhaps, Lucia, we can say that in NFPA 502, this is being discussed as we speak. And hopefully there will be some more clear language in the next NFPA 502 document. And the argument we are bringing forward, all of us basically, to change the language is that the basic principle should be that the doors and the walls in which they are mounted should have basically the same rating. And rating is a bit of an obscure phrase as well, because you can have the fire curve and the fire resistant time, as well as the criteria, which all may be slightly different. But the basic position should be that they are considered the same, and depending on the function of the room, say behind the door or the corridor or whatever, which is behind the door, you can perhaps change a bit your viewpoint, but the basic design criterion should be that the principle is the same fire rating, the same fire curve, and the same fire duration. But this is a heavy debate at the moment. But it seems illogical that you have a door which might fail in like 5 minutes, or 30 minutes for that matter, if the wall itself needs a 2-hour fire rating. So good question, and hopefully in the next session we can perhaps dedicate a specific topic on this item. Then, in view of the time, I think we need to go to the last question from Kuldeep. Which system, a spray mortar or a board, is appropriate for RWS and tunnels, and advantages of each?
Okay, so yeah, you can use them both for the RWS fire curve. I think the main advantage of a spray applied system is that you can spray it on a surface that's not flat, of course. So if you have a bore tunnel, it might be easier to apply with respect to a board system. On the other hand, if you want to do inspections behind the fire protection system, a board system might be more appropriate and easier. So you can detach or deinstall the boards and have an inspection after the system, which is not possible with a spray applied mortar because it's applied to the concrete, so you cannot detach that. So I think that's for now what I can come up for now.
Thank you, Jos. Yes, it depends on a case-by-case situation, of course. And both systems have advantages and, say, challenges. And it depends which tunnel and depending on the time that is available to install, as to whether or not you have an immersed tunnel and so forth. So it's difficult to give a concrete preference on either product in general. We are close to the hour. There are a couple of other questions in the chat. We could perhaps address one or two. So a question perhaps on what is the typical fire protection duration for passive fire protection? I guess that's a matter of what's design fire scenario. Is it 30, 60, 120 minutes, or perhaps even longer?
Yeah, well, maybe I can only talk about the Dutch case, but in the Netherlands for land tunnels, so tunnels not under open water, it's usually 1 hour, but sometimes also 2 hours, depending on if, for instance, buildings are close by a tunnel. For tunnels under open water, it's usually 2 hours. But I've also seen for other projects in Asia that they sometimes use a 3-hour requirement. But I think normally for most tunnels, it would be 2 hours.
Okay, thank you. Maybe time for one last question. What is the possibility of passing tests specified by using reactive fire protection systems, that is intumescent coatings?
Sorry, I didn't quite hear you, Kees.
So what is the possibility of passing any of the fire tests which are specified, which you discussed, by using a reactive fire protection coating?
So I think at this moment in time, no system is on the market for tunnels in terms of an intumescent system that can be applied to concrete. I know that there are some developments in the market, but developments are not in such a state that it can be that they can go to the market and sell it and apply in a tunnel. So for what I know, such a system at the moment does not exist that can actually withstand a 2-hour RWS fire test.
Okay, thank you, Jos. We're just shy over the hour, so I suppose we go to the concluding remarks, and thanks for those who posed the questions. And we'll try and put the Q&A session in writing as well on the PFPNet website, I suppose, John, but maybe back to you to see how we handle this. Thank you.
Okay, right. Well, thank you, Kees, and thank you to our presenters very much indeed, and to all of you for attending. That brings us to the end of the session, which I hope you found interesting and informative. A couple of points to make on this. In terms of the guidance document, as you have signed up to the this webinar, you will receive by email a copy of the guidance document for your use, and obviously look into it further. With that will come a request, please, and the request is basically going to be some questions to you as to what you feel is important, relative, and something that we could do as PFPNet further in terms of fire protection of tunnels. So it's basically going to be a brief question or questionnaire to you, which we would very much appreciate your response to. The other thing to mention is that, yeah, and by the way, there will be an email address, my email address, within that communication where you can send the questions to. I will then forward that to our group, and you will receive a response back directly to the questions, and potentially we can also answer some of the other ones that have come up today during that as well. The final point to make is that PFPNet will be holding our conference in Amsterdam on the 21st and 22nd of October. We very much want to put tunnels into the agenda and have presentations on tunnels. And if there is anybody who has anything that they would like to offer forward for that relative to this subject, even if you're a non-member, we would be interested to hear what you have to say. But talking about membership, obviously PFPNet only exists and continues by virtue of having members. So if you have enjoyed today's webinar, could I please encourage you to go to our pfpnet.com website, take a look at what we do, and please consider joining PFPNet, because I know very well that PFPNet only works by virtue of having members in it who have an interest in this subject and an interest in taking it further forward, and in, as I said in the outset, increasing the knowledge and understanding and competency in this very important area. So please take a look, please consider membership. Companies who join exactly as that, as a company. So it's not, it's not divided amongst various areas. You will get membership for your whole company, whether you're in more than one location or not. So thank you again. I think that concludes the webinar. Thank you for joining. And again, thank you to our presenters and Kees for doing the questions there. Thank you very much indeed, and hope you have a good day.